Lesson 2.5, Reason Using Properties from Algebra. This lesson might seem a little easy in the beginning, but I would like you to focus on the different properties that you will be using in future proofs that may be more complicated. Algebraic properties of equality. Let A, B, and C be real numbers. So we have the addition property. If A equals B, then if we add C to both sides, the equation is still balanced. Subtraction property. If A equals B, then A minus C equals B minus C. Multiplication property. If A equals B, then A times C equals B times C. Division property. If A equals B and when C does not equal to 0, then when you divide by C to both sides of the equation, it is still balanced. And then we have the substitution property. If A equals B, then A can be substituted for B in any equation or expression. So even though this looks very easy, when you do more difficult proofs later, which involves more geometry, you might forget to use some of these simple properties, but they can be very useful. Okay, so let's start simple. Example 1. Solve 2x plus 3 equals 9 minus x. In Algebra 1, you didn't have to show a proof, but now you do. Write a reason for each step. So for the first one, the reason is given. There's nothing you can do there. And for the next step, you want to add x to each side because you want to cancel this out. So that would be the addition property. And the next step, you will have to take 2x and add it to the x. So that will make 3x. And this will be 9. So this will be combined like terms. So we're just simplifying. And this, we're going to have to subtract 3 to both sides. Subtraction property. And then x would equal to 1. Divide each side by 3, the division property. Okay. The focus here is not in solving for x here, because this is a geometry class. We are focusing on the reason. Now this is easy, okay? But in order to do more difficult proofs, you need to understand the basics first. And now, lastly, we have the distributive property. So this is a review. A times the sum of B plus C is equal to A times B plus A times C, where A, B, and C are real numbers. Okay, let's try example 2. Write a reason for each step. So first, it's always given, the first step, and then we're going to have to use the distributive property for the next step for the left-hand side of the equation. And then we will get distributive. Now we need to add 8 to both sides. So that will give you negative 24x equal to 72. Add 8 to both sides. Now we're using the addition property. And then we solve. X equals negative 3. You're dividing both sides by negative 24. And that will be the division property. Now, I would like you to pause the video and try example 3 on your own, and then continue to play the video to check your answer. So here are the answers. Now, try example 4, and then continue to play the video after you are done. So for example 4, you're not actually solving for a solution. You're just rewriting the given equation in the word problem in terms of the speed. So S would equal to D plus 17.5 divided by 3.5. And first, you would always write given for the problem, and then you will have to use a distributed property, followed by the addition property, and then the division property. Okay, now let's move on to a couple more properties that will be very helpful for future proofs. So here we have the reflexive properties of equalities. Okay, when you have real numbers, for any real number A equals A. For segment, AB equals AB. For angle measure, for any angle A, measure angle A equals measure angle A. For symmetric properties of equality, for real numbers, for any real numbers A and B, if A equals B, then B equals A. For segment length, for any segments AB and CD, if AB equals CD, then CD equals AB. And for angle measure, for any angles A and B, if measure angle A equals measure angle B, then measure angle B equals measure angle A. And then the transitive properties of equality. This is going to be a very widely used property here. For real numbers, for any real numbers A, B, and C, if A equals B and B equals C, then A equals C. So if you look at it vertically, it would be like that. And for segment length, following the same logic, if you have segments AB, CD, and EF, if AB equals CD, CD equals EF, then AB logically will be equal to EF. And for angle measure, for any angles A, B, and C, if measure angle A and measure angle B is equal to measure angle B, and measure angle B is equal to measure angle C, then measure angle A equals measure angle C. Now let's look at example 5, and it's more of a geometric proof. And we would like to show that segment CF is congruent to segment AD. So I need to analyze this picture here. What are my given information? I see that AB is equal to EF, so I'm going to write that down. I also see that BC is equal to DE. And my reason would be given for the first step. And now I'm thinking, to prove this, I can take the total length AC and add it to CD and set it equal to DF plus CD. But I need to break this down here. Let's begin with AC. AC equals AB plus BC by the segment addition postulate. And then DF equals DE plus EF, also by the segment addition postulate. And then I'm going to use my given information here. I'm going to substitute in DE for BC and EF for AB. So I'm going to write substitution property. Now, since AC is equal to AB plus BC, and DF equals to BC plus AB, which is also AB plus BC, referring to the same segment, by the transitive property, I can say DF is equal to AC. So again, this would be A equal to B, B equal to C, so A equal to C. Okay, so lastly, I can add, which I was talking about earlier, I can add this segment CD to both sides of the equation here by the addition property. And therefore, DF plus CD will be my CF, and then AC plus CD will be my AD, and this will be substitution property. And I have proved it. And this will end the lesson for now, and we will continue to solve more difficult proofs in class.